Hey y'all, what's up? Okay, so I've been, talking about making a world record of derivatives, right? 150 of them to be specific. And so, yeah, we're gonna get our start here, right? We gotta get on with it, because, I made that promise a little bit ago. Also, like, real quick, is like, well, I suppose Salvador is part inspiration and pushing me along. Maybe part inspiration is trying to impress this girl that I'm like madly in love with. Like I fall in love every 7 years, and they got me. Like they set up the perfect trap. They know I could resist, and she's like an L, right? Pretty enough to make the cover of E, right? And I'm so funny, and and to like, oh Christ, like why and what is it, yeah, so what is it, told me about how like she wasn't noticed like by her high school soccer coach and stuff, so I could relate, right? Like, so I auditioned for like the varsity team of my high school, right? And the varsity coach like immediately loved me, right? Like, cause like with soccer players, like, I don't know about you, but I can tell, like, just after a couple touches, just how good that person is. So he saw, but then I was really weak. Like, I'm still, like, not a macho man, right? And so, like the guys who were auditioning, they wanted the spot so bad that they kept on, like, pushing me, and, like, I kept on falling, and I made one or two bad passes. And so, like, the varsity coach is like, yeah, gonna pass me on to the, the JV. And I just didn't even go audition for the JV because I was so mad, because I was probably like better than every varsity player or whatnot. I was just like a little weak. And what is it? No, I know physics really well, so I can like trip like guys much bigger than me and stuff. You know, it's all about that. Okay, these days, yeah. But like then I switched to like a Somalian team, an all Somalian team. I was the only non-Somalian on the team, right? Everyone's like much bigger than me, right? And the coach loved me because I'd score like 4 goals a game or whatnot. But yeah, I'm using all this kind of like plead with the girl, which is like, so like I don't know if you've ever talked to like Somalian, a legit Somalian, not someone like who's born here or whatever, like, or the ones who live in Canada or whatever. And like, you know, like I'm not making fun of dyslexic people, but Somalian people like be mixing up their P's and their B's, right? So like instead of pass the ball, they'll say boss the ball or some shit like that, right? So like, so my pleading with the girl is like, but please don't break my heart. but please don't break my heart. Okay, let's get on with this. Yeah, okay, cool. All right. I was recently tutoring a student in calculus, and I came across this, and so let's find the derivative. Right now I have videos on the fundamental theorem of calculus. It's really cool. Check them out. I even show you how to prove it 4 different ways, right? Okay. So here, to find the derivative of this, we have to employ the fundamental theorem of calculus. So again, because I've talked about that in its own dedicated videos, and I'm not going to talk at length about it here. But what we do, right, is like to find f prime, the derivative. We take this, we ignore the constant, we take it, and plug it in and apply chain rule, and so multiply by the derivative of this. Again, if you want to know why you've got to do this, watch my videos dedicated to the fundamental theorem of calculus, right? So it's like 3x to the 4th cubed, and then, so what I did is I took this and plugged it in there, and then multiply by the derivative of this, and that's 12x cubed, right? Yep, okay, and obviously there's a bit of simplifying that we could do, so it's like 3 to the 3rd is 27, right? So 27, and then x to the 12th, and then times 12x cubed. So that makes 27 times 10 plus 2. That's 12, combining the numbers. And it's x to the 15th, right? What is this? 270 plus 56, x to the 15th. And 270 plus 56 is 270 plus 30 plus 26, so that's 326, right? So 326 x to the 15th, right? Okay, Please don't break my heart. Okay, alright. Let's move on to 2. But I gotta erase first. So, problem 2, and just to, like, make this fun, somewhat exciting. Every 10 problems, I'm gonna change my outfit, something like that. I don't know. But once again, we're gonna have to use the fundamental theorem of calculus. And again, well, I said that I have videos dedicated to it just to help you on a hint on where you should apply the fundamental theorem of calculus. It is in a situation where you're taking the derivative of an integral. And another clue is that, like, in doing that, taking the derivative of the integral, you should see that whatever variable is used in the integrand ought to be different from the variable used on either of the 2 limits of integration. On simpler problems, the lower limit or the upper limit will just be a constant, and of course the other limit will have a variable in it. Again, once again, the variable and the limits being different from that which is used in the integrand. Whereas, like, on harder fundamental theorem of calculus problems, it will be like both limits involving a variable. Once again, the variable different from what's in the integrand, right? Okay. So this is much like the first problem that we did. So to find the derivative here, f prime of x, all we have to do is plug this in for t and then multiply by the derivative of this and simplify. So that means that we write square root of 4 plus 7x to the 5th to the 5th, right? And then times 35x to the 4th. So this is going to say 35x to the 4th times the square root of, and then it is 4 plus 7 to the 5th. Do I care what that is? It's a big number, that's all. And then x to the 5th is x to the 25th. And this is as far as I'm going to simplify. Again, all that's left to do is figure out what 7 to the 5th is, and that's not a big deal. And here, f prime of x, we have a special situation of the fundamental theorem because, well, both the upper and lower limits involve variable, right? So what you do in this situation is not very different from what we did here, slightly more work. So to start, you take this upper limit and plug it in for t, multiplied by the derivative, so much like how we did the other ones, right? 4 plus, and it's x cubed to the 5th, and then times 3x squared being the derivative of that. And then it's minus, square root of, this time we plug that in, right? Kind of predictable, 4 plus, and then it's 5x squared to the 5th, and multiply by the derivative of this, that is 10x. Right? Now, why it's got to work out this way? Well, as I said, I have videos dedicated to the fundamental, and I prove it in 4 different ways, so you can watch those proofs to figure out why it's got to be this way. Yeah, okay, but if we simplify here, we have 3x squared, and then 4 plus, this is x to the 15th, and then minus 10x square root of 4 plus 5 to the 5th. What's that? Do I know what 5 to the 5th is? I used to, but yeah, do I care? No, it's a large number. It's 625 times 5, right? So that's 6 times, sorry, whatever. I could figure it out, but I don't think it's impressive or important. 5 to the 5th, and then x to the 10th, right? Yeah. Right? Okay. Yeah, okay. That's about as much as I want to simplify it, yeah? Okay. This is nice enough to get us started, and we'll continue. Oh, shoot. I'm not supposed to do that. Alright, love Christ, be with everyone, as you are always with me. Thank you.